So here I'm talking about the fourth homework, which is a short homework. As we said before, we are going to split this last homework in two pieces. The first piece is about sections 3.5, 4.1, and 4.2. Okay. So the first problem we have basically is about section 3.5, which is about matrix completion. We have two sub-questions here. Okay. Here, first of all, we'd like to find the matrix S, which is 3 by 3. So you have to find to complete this item A, B, C, D, E, F, G, H, Y, I. The matrix S should have the least or the smallest L2 norm, such that it solves the system. S times 342 equals 100. So S multiplying 342 needs to be equal to 100 with the least possible L2 norm. Okay. Second question in this matrix completion exercise, we have to find all possible, all possible matrices. Okay, with these missing items that solves the following minimization problem, where you're seeking the vectors here C and R. So as I say, CRT is 2 by 1 multiplying a 1 by 2. Okay? So what do you minimize? You minimize half of the L2 norm squared of A minus CRT on the known parts. Okay? The L2 norm squared of A minus CRT multiplied by half plus half of the Frobenius norm squared of C plus the Frobenius norm squared of R. Okay? You should be able to have many possible solutions, and that's why I'm saying all possible matrices. Of course, many possible solutions when I say that minimize, not that maximize. Huh? Possibly. Okay? Of course, here can I add a note, guys? I'm adding the note here that C, the elements here in C and R could be in the complex set. Okay? The elements, did you hear me well? The elements of C and R could be in the complex set. I mean by that the entries on A could be in the complex set, as we don't have any let me say, just for the joke, any complex dealing with the complex numbers here inside our matrices now. Okay? Now, second problem is about Fourier transforms. So in the first sub question, I'm giving you this vector 2, 3, 4, 1, this coefficient vector 2, 3, 4, 1, and I would like to find y that equals the Fourier matrix F times C by a one-step fast Fourier transform. First of all, you do it manually. Okay? Then you do it using MATLAB. If you understand well the content of this section, which is 4.1, especially at the end, it should take you less than 10 minutes to do the whole problem. Okay? If you don't understand now, most of the work is done before trying to solve the exercise. You have to understand what we're talking about in section 4.1, especially at the end. That fast Fourier transform, okay, and how you have to do this. And secondly, verify that F, which is equal to 1 over 4 F times C, okay, is equal to half y. Okay? Verify that F, which is 1 over 4 multiplied by FC, is half times y. Which y? The y that you got here. Okay? Manually and MATLAB. Last question, and that's it. 4.2. It's about shift and circulant matrices. Actually, this question is on 6, not on 7. I forget to change. So we have two matrices C and D which are circulant matrices, and describe it this way. So C is I plus 2p plus 3p squared plus 4p cubed. And D is 4I plus 3p plus 2p squared plus p cubed. And we'd like to show the following. That is what we've seen in the class, in the last part of this section. That F inverse times C times F multiplied by F inverse times D times F is equal to F inverse of CD times F, which is the eigenvalue matrix of C times the eigenvalue matrix of D, which is equal to the eigenvalue matrix of C. Here I'm giving you the note that capital lambda of the matrix is the diagonal matrix containing the eigenvalues of that matrix. F, of course, here capital F is the Fourier transform matrix. And P is the shift matrix, as you know, of size 4, okay, which is used to compose these circular matrices. Okay, is that clear for everyone? So here I just described what we've posted yesterday about this before last homework, which is kind of half homework. Any question on this, guys? Hopefully all is clear.